Hello everyone, welcome to my channel Calculus Help Now, where we will be working on multivariable calculus. For this playlist, I know I'm starting a little bit weird in my channel. I'll be working hopefully on Calculus 1 and Calculus 2 playlists. If you find my videos useful, please let me know down in the comments. Let's get right to it. We'll be working first with vectors and the geometry of space part 1. So let's draw something you guys are probably familiar with by now. It's an XY plane, and any point on an XY plane can be represented by an ordered pair AB of real numbers, and what you guys will be transitioning into will be a three-dimensional coordinate system. So you guys would probably have to practice drawing this. So let's say it goes like this. And then like this. So this right here would be the z-axis, z. This would be the y-axis, and this would be the x-axis. And all of these axes would create three coordinate planes, and they would eventually get to 8 parts. There would be 8 parts divvied up to be called octets, and the first octet would be the plane in the foreground. So as you can tell, I drew them pretty interestingly, because you could tell that the farther I go down, the thinner it gets, and that's on purpose. The farther away we go, the thinner it gets, because it isn't just a flat plane. It isn't just an XY plane. It's in three dimensions, and that's how we live our life. We live our life in 3 dimensions, and the farther away something goes, the smaller it would get, and the closer it gets to you, the larger it appears. So this part would represent a positive z-axis. This would be the the positive y end of the y-axis, and this would be the positive x end of the x-axis. And the farther you go in this direction becomes negative. So this is the negative end of the x-axis. This would be the negative y. This would be the negative end of the y-axis, and this would be the negative end of the z-axis, right? So I try to draw it so you guys can understand that the farther you go, the thinner it would appear, and the thinner, I guess, the thinner parts of my drawing would represent the negative ends of the 3 axes. And let's just say any of these points, let's just say a point right here, any of these points in space are represented by an ordered pair, an ordered triple actually. This would be an ordered pair because there are 2, an ordered triple labeled as A, B, and C. So this is probably something you guys have never seen. This is the new component of this ordered triple. And if you guys have a hard time visualizing this, I understand that many students find it pretty difficult to visualize it at first. You can just think of the corner of your room. Let's just say we draw it again, so like that, right? Think of this as the corner of your room, and let's just say you have carpet here. And let's just say you have a nice plasma screen TV just hanging on the wall. On the right side, this would be the right side of the wall. This would be the left side. Say you have a nice family portrait, family photo on the left side, and this would be the bottom. This would basically be the floor. This is the floor. So there's actually one last idea that there's actually something that may help you in drawing this three-dimensional coordinate system. So let's draw it again. One last time. Just drawing it quickly. Right? Is the z, y, the x, and this is the origin. So if you actually use your right hand and you use your thumb, so let's just say this is your thumb, and apologize for the horrible drawing. This is your thumb going in that direction. Your thumb. You have your pointer finger pointing in the positive x direction. And then finally you have your middle finger pointing in the positive y direction. This idea is actually called the right hand rule. And with this idea, you can actually do it yourself. You would use your right hand, you'd use your thumb and point it up vertically, and you sort of shoot your pointer finger past you, a little bit past you, sort of towards you, but a little bit past you. And you basically roll your next three fingers, and we're specifically focusing on the middle finger, so you'd kind of point it to the right of you, if that makes sense, and it should create the three axes that make up the three-dimensional coordinate system that this entire chapter or even course that you'll be learning about, that you'll be using, it'll give you a nice three-dimensional coordinate system. So we're asked to sketch the points 1, 5, 3, -2, -3, -1, 0, 5, -1, and -2, 4, 5. And as usual, we're going to draw our 3D coordinate system. And I will start with the z-axis. So, watch out. Apologize about that. I'm going to draw a better one. Seems fine. Z-axis. And the x-axis. And then finally, the y-axis. I'm going to draw 6 of these lines. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And finally, 1, 2, 3, 4, 5, 6. Seems about fine. So we're going to start with point number 1. And I'm going to represent point number 1 with a reddish color. So as we already know, this would be the x component, the y component, and the z component of this point. So I'm going to write it down. X equals 1, y equals 5, and z equals 3, right? So we're going to move in the positive x direction, so this way, 1 unit, right here. And then we're asked to go 5 units in the positive y direction, so 1, 2, 3, 4, 5, right? So we're actually going to draw a dotted line parallel to the y-axis. So let's draw our dotted line. Make everything easier and more accurate when drawing our point. Then we will draw another dotted line parallel to the x-axis now from the y-axis. So, about right here. And we want to make sure these dotted lines intersect at some point. So this would be the point. And then finally, our last component, which would be the z component, we're asked to go 3 units in the positive z direction. So 1, 2, 3. Then we would draw another dotted line from the origin, which would be right here, striking this point of intersection right here. And then finally, with the 3 units in the positive z direction, we draw another dotted line parallel to this dotted line, the one we just drew. So we would continue on until we reached about, here seems fine, something about, yeah, that seems fine, something that would align with the point of intersection that you drew from your x and y component, which would be about right here. So this seems like an appropriate place to place this point. So 1, 5, and 3. And it may seem a little bit odd at first, just because you're new to this stuff, and it may not seem that this would seem like an appropriate place to place this point, but in actuality, just because we're dealing with 3 axes, not 2 axes like you're used to doing, you're used to plotting points on a flat surface in a 2D coordinate system, but in calculus 3, we actually have to take into account the 3 axes and the fact that it's in 3 dimensions, and we live our life in 3 dimensions. And if you really put that into perspective, you can really visualize that it would be found around this area. So for our next point, I'll represent that in a bluish color. So again, we have the x, y, and z component. X will be equaling -2. Y would be equaling -3, and z would be equaling -1. So we would move in the negative direction on the y-axis, so it would be that way, right? So 1, 2, so about right here. And then next we have y equaling -3. So 1, 2, 3 in the negative y direction. Then we would draw more dotted lines parallel to the x-axis, branching out from the y-axis. And then another dotted line branching out from the x-axis parallel to the y-axis, so just like this. And then again, you have your point of intersection about right here. And then at z equals -1 would be found just below the origin. And you draw another dotted line from the origin to the point of intersection, about like that. And then you draw another parallel line from z equals -1. It would be parallel to the line you just drew. And that would seem like an appropriate placement. Remember, it must align with the point that you just created at the point of intersection. It would be about right here. Would be a good place to put it. So that would be the point -2, -3, -1. Next, we have another point, and I'll represent that in a greenish color. So again, we have the x component, the y component, and the z component. X will be equaling 0, y will equal 5, and z would be equaling -1, right? So 0, we actually remain at the origin, because that's where we start. We remain at the origin, and we move 5 units in the positive y direction. So 1, 2, 3, 4, 5, right here again. And it would be z equals -1. So we draw another dotted line parallel to the y-axis. So z equals -1 right here. Draw another dotted line parallel to the y-axis, and draw another dotted line branching out from the y-axis parallel to the x-axis. So you'll find your point of intersection, and at that point, that's actually the point that we're trying to find. This is actually a good place to put our point: 0, 5, -1. And finally, hopefully everything is making sense so far. We will finish off with a yellow color. This will be an x, a y, and a z. These will be 3 components making up that ordered triple. X will be equaling -2, y will be equaling 4, z will be equaling 5. So again, we'll move in the negative x direction, which would be about right here, and y equals 4. So it would be moving 1, 2, 3, 4. And again, we're going to be drawing more and more dotted lines. So this dotted line would be parallel to the x direction, and we draw another dotted line from the x-axis parallel to the y-axis. And at this point, you'll find your point of intersection. And last but not least, we'll have a z component of 5. So we move 1, 2, 3, 4, 5 in the positive z direction and draw another parallel line that is parallel to the last dotted line you just drew. And remember, as you're plotting these points, try to really imagine in real life how this would actually look. It makes everything much easier than relying on these dotted lines we drew. But they definitely do help in locating this point. So this seems about right. This would be our final point, which would represent -2, 4, and 5. Now, if you have any comments, questions, or concerns, please don't hesitate. Just scroll to the bottom and write write it in the comment section. If you want to give me a like, if you want to subscribe, or if not, just I'd encourage you to come back to my channel because I'll be uploading more videos on Calculus 3. I'll be uploading videos on Calculus 1, Calculus 2, differentials, and hopefully linear algebra. So any support would honestly be really awesome. And one more thing, I understand that this subject can be very daunting to many students, and fortunately, I've had a lot of success in tutoring a lot of my peers and a lot of students on campus. So don't worry, you're in good hands. Just, keep hacking away at those problems. You'll definitely start to ingrain the sort of ideology and the sort of mindset at understanding on how to tackle these problems. So I hope you have a good day.